Hey, good morning, everyone. So today I'm going to do a lesson about the periodic table. So you might have seen it before, maybe in Monique's classroom. She has a poster of it above the whiteboard. Um, but yeah, so we're just going to go through it today. I know that she made a video already about like what each of these specific squares look like. So this lesson is going to be more the periodic table, like on a general level, like the whole thing. So here's the periodic table here. And you can see that it's broken down between, well, you can break it down between metals and non-metals. We're going to look a little bit at that today, as well as groups and periods, which we're also going to talk about today. So if I just click on here, you can see that pretty much the whole periodic table consists of metals. Everything like on the left side of the periodic table and like going into the right side, they're all metals. And then you can click on the non-metals and you can see that there are a lot fewer of them than the metals. Yeah, so we're just going to take a look at it here. So here it is again. You can see that each of these different vertical columns, they all are color-coded because they all have similar properties, which we're also going to be looking at. They all have specific names too, so these ones are alkali metals, these are alkaline earth metals, you have the transition metals here, there's the metalloids that go down this little staircase down the middle, you have your halogens here and your noble gases, and it's really nice that it's organized this way. Like, it's good that all of these things have common characteristics so that we can make a table that looks like this. So you might also be wondering why there are these two extra rows on the bottom. So this purple pinkish row fits in here and this red one fits in here. So that's because in those particular rows there are so many elements that can fit in there that it just made sense to like put them down underneath. It's not the best solution, but it works okay. So yeah. So another thing is that the numbers in the periodic table, they're arranged, I should say, the elements are arranged by increasing atomic number. So we start at the top left corner here, and that one is hydrogen, so it has an atomic number of 1. Then we go all the way across here to helium, has an atomic number of 2. Back to the left, it's like 3, and then beryllium is 4. And 5 and 6 and so on, and it just goes from left to right, just as if you're like reading a book or something like that, and it just keeps going up by 1 each time. Another thing to point out is that there are 7 rows, so 1, 2, 3, 4, 5, 6, 7, and we don't count these bottom 2 because technically they're part of the 6th and the 7th row. So we're gonna be using that a little bit later. Another thing too is that there are 18 groups. So 1, 2, 3, 4, and you can keep counting all the way. This last one here is 18. And here we are again. So it's just showing you there are indeed 7 periods and 18 groups, or 7 rows and 18 columns. So this is what Monique was talking about in her video, I believe, just about the different things that you can see in each square. Sorry, these arrows are a little bit off here. But this number here at the top right is the atomic number. So I showed you that in the general periodic table. And each element goes up by 1 each time. Remember, the atomic number is the number of protons that an element has. And we said that as we add another proton, it becomes a new element. Each element also has a symbol, so there'll either be 1 or 2 letters, and it's the first letter that is always capitalized in the symbol. So just for example here, this element is hydrogen, and it is a capital H. Each element also has an atomic mass. So we said before that the mass is made up by the protons and the neutrons. If you look in the periodic table, it's always going to be a decimal number, but like obviously we can't have like a fraction of a proton or a fraction of a neutron or anything like that. So this number represents the average of different forms of that element that we can have. Different isotopes is what they're called. We're going to take a look at isotopes shortly. And then there's also a number here with the number of valence electrons, which we're also going to talk about today. But basically the valence electrons are just how many electrons are on the outside of the element, in the outer shell, the outermost shell. So all electrons are on the outside of the element, but the valence electrons are the ones that are furthest outside that can be used for bonding and combining with other elements. We're also going to look at that too. So like I said, the atomic number refers to how many protons an atom has. No two elements have the same number of protons. If they did, they would be the same atom. And the atomic mass, so that is like the weight of the atom, and we find it by adding the protons and the neutrons. So here we're just going to talk about isotopes a little bit. So while most atoms of an element have the same number of neutrons, some of them don't. So here are some examples here. Here's hydrogen. Hydrogen, as we know, has an atomic number of 1. That means it has 1 proton, which we can see here by the red circle. But hydrogen can have a different number of neutrons. It can have 0, it can have 1, or it can have 2. So these are all different forms of hydrogen, which are called isotopes. So they're still hydrogen, they have different forms. You can see the same thing here with helium. This helium has 1 neutron, this helium has 2 neutrons, but they're both helium. And then the same thing here with lithium. And different neutrons means that the element will have a different atomic mass for each one. So here we have 1, 2, 3, 4, 5, 6, so it has a mass of 6. Here 1, 2, 3, 4, 5, 6, 7 has a mass of 7. So when we talk about different isotope formulas, we write the symbol with the mass with a dash in between. So hydrogen, there's H1, H2, and H3. For helium, we would call it H3 and H4. So that's because this helium has a mass of 3, this one has a mass of 4. And then with lithium, there's lithium 6, lithium 7, and you can see the 2 different forms here on the right. So talking about valence electrons, like we said, valence electrons are the electrons in the outer energy level or the outer orbit of an atom. So they are the ones furthest on the outside of that atom. So just looking at this picture here, this one has 2 in its first shell. It has 1, 2, 3, 4, 5, 6, 7, 8 in its second shell. And it has 1 and 2 in its third shell. So we would say that this element has 2 valence electrons. So we just count the ones that are on the outside. So these are the electrons that are transferred and shared when atoms bond together. And how many valence electrons an atom has greatly affects its reactivity. So an atom's goal is to always have a full outer shell. So usually that means that they want to have 8 electrons on the outside. The exceptions to that are basically the ones at the beginning of the periodic table. So helium, hydrogen, lithium, beryllium, elements like that, they only need to have 2 electrons in their outer shell. And that's just because it's easier for them to like gain or lose to get to 2 rather than get to 8. So basically for those elements, they just want to get to this inner shell here rather than try to fill up their outer shell. So they like to find the quickest way to get it. So atoms with fewer valence electrons want to get rid of their valence electrons, and the ones with more valence electrons are going to want to fill up their shell. So atoms that have fewer electrons to fill in a giveaway will be more reactive than others. So I'm just going to go back to the periodic table here. So like elements here, for example, in the first column, they only have 1 electron in their outer shell. So they want to get rid of that 1 electron and just have like, then it'll go to like the next shell and it'll be full already. Same with these ones here in this second to last column. They have 7 valence electrons, so they only need to gain 1. They would rather gain 1 than lose 7. It's a lot easier for them to just gain 1. Alright, so we talked about that the periodic table is mostly metals. So all of these blue ones here, those are all metals. There are also non-metals, which are these green boxes here. And then there's the metalloids, which are like, they're sort of in between the two, and it is this like pinkish purplish staircase that goes along the middle there. So there's only a few of those. And just a couple more things here. There are a couple of properties that might be useful for you to know. So atomic radius. The radius is basically like how big an atom is. So just one thing to know is that atoms get bigger as we move to the left and as we move down. So the element that's in like the bottom left corner of the periodic table is going to have the biggest atomic radius. And electronegativity. So it is the ability of the atom to attract another electron. So that is pretty much is more off the right side of the periodic table because they tend to either take electrons from the metals or share electrons with other nonmetals. But, oops, sorry about that. But yeah, you can see that on the right side of the periodic table, these bars here are a lot bigger, and that's because they are more likely to attract electrons from other elements. So this is called electronegativity. So those, like that and the atomic radius, they become more important generally in higher level chemistry, but they're still good properties to know for you guys. So I think that's it for today. If you have any questions, feel free to email me or get in contact with me somehow. Otherwise, have a good day.